Good morning, afternoon, evening, everybody, wherever you are. My name is Brandon Archuleta. I'm a student at Grand Canyon University, and I am currently taking Introduction to Information Technology, ITT 111, under Professor Lisa Gasco. For this assignment, I am going to be going over, um, it says top 20 SOOPy terms, but for me, I personally like to say just 20 SOOPy terms that I kind of found very relevant just based on the research that I've conducted. Now, getting right into it, what constitutes a SOOPy term? SOOPy terms are terms that are relevant to security and object-oriented programming, or OOP. In this presentation, I'm going to be covering 20 of the terms related to these concepts. There are a lot of terms. I'm not even going to get close to covering them all in this short little video, but I'm going to be going over some of them. And I am by no means an expert, so I'm definitely going to be sticking to the information that I've collected. Continuing on, class. What is class? In object-oriented programming, a class is used to define the properties and the behaviors of an object. Essentially, I kind of like to think about it like categories. Like classes are the categories that objects fit into. Next, we have object. An object serves as an instance of a class. All values are defined by either the user or the default settings. So that's kind of like the information that you put in that does get put into those classes. Next, we have instance. Now, this term, a little bit controversial. I have seen it used kind of interchangeably with object, but I've also seen that it can be used to refer to the relationship between an object and its respective class. This is accomplished by providing the purpose for which the class will be used. Pretty interesting. Next, we have data fields. Data fields very simple. That's used to represent the information about an object or class, and that's going to be just defined by the user. Next, we have attribute. Attribute is a defining property or value of an object in OOP, object-oriented programming, and it can also define a class as well. Next, we are going to be going over behaviors. Those are the things that define the actions that an object performs. Now, this is a little bit different from attributes because it does not define the aspects of an object or categorize them like classes do. So sort of like classes, but they're still a little bit different. Method / function. Now, the reason I put those together and put that slash in there is because I have also seen these ones kind of used interchangeably, but these are two terms that are used to represent the functions assigned to specific classes that can be performed by the objects within that class. Pretty simple, just kind of one of those defining things. Continuing on, we have interface. Somewhat similar to a class, an interface describes all functions an object must perform to be identified as an X. So, in order to be considered something, an interface helps to kind of differentiate how that object fits into whatever that category is, but does not allow for implementation like classes do. Similar to classes, but also different. Next, we have default value. Default value is the one that automatically gets put in. So if you have a field, you don't put anything in it, you're going to get a default value. This might be a random number, just a collection of numbers, characters, whatever, or it might be a 0 or a null value. Continuing on, we have encapsulation. Now, this is where we start to get into some of those bigger concepts. This is one of the 4 big concepts that object-oriented programming is actually built upon. Now, encapsulation is the compiling of data into a singular unit. It also allows for restricted access to some data. Yep, so kind of puts it all together and then makes some data not accessible to your average user. Inheritance allows a class to undertake the properties of another pre-existing class. Essentially, it allows for code reuse. This kind of describes that whole parent-child relationship that classes share with one another. Next, we have polymorphism. This is another one of those big pillars. This one allows classes and objects to take different forms or actions depending on the context in which they're used. So for example, I put a cursor taking on a different shape depending on the situation. A cursor might look like a nice little arrow. You might click on something, it might change while it's loading. You might see the little hourglass. I know that was really popular in some of the older versions of Windows. Continuing on. Abstraction. This is going to be the last of those big four pillars surrounding OOP. Abstraction is used to promote simplicity and reduce complexity by hiding all non-pertinent information. So it's going to show all that relevant information at first look. And then if you want to see that other stuff, you're going to have to be one of those administrators that can kind of dig down. Next we have modularity. This is the process of breaking down a larger program into smaller modules to reduce the overall complexity. Essentially just kind of breaking down things into chunks to make it a little bit easier to manage. Process isolation. This is when the aspects of a program or software components are not able to access the internal information of the other. This allows for communication but limits access to internal data. So essentially allows things to operate simultaneously without one kind of affecting the other. Domain separation. This is the separation of information and the process into defined domains to promote data security, meet user needs, and maintain a hierarchical model. Now, this separates information into domains, essentially kind of affects the way that that information will be accessed. Next, we have the hierarchical model. This is the concept that allows for classes and objects to be ranked according to their importance. This also defines the order in which processes such as abstraction are done. This kind of feeds into something we're going to be talking about a little bit later, the least privileged model, but we'll get into that in just a bit. Next, we have open design. Also known as the open-closed design principle, this allows for information to be open or closed depending on whether it needs to be accessed for the extension of services from a parent class or closed for the modification of services. In other words, the program in question could be extended without having to worry about the modification of its source code. So very important concept there. Defense layering, starting to get into some of that security stuff. The intentional addition of redundant defenses to block a wider variety and increased amount of attacks. So very important security concept there. Least privilege. One of our last and one of the big security concepts as well. This is a security principle in which users are given the least amount of privilege necessary to perform the functions relevant to their position. For an example, on a web store, a customer would be the one that has the least privilege because they only need to browse and shop. From personal experience, when I was in the military, I was an operator. So when I would operate on our computer systems, I was given the least privilege out of everybody because that's what I needed to perform my job duties. Whereas the maintainers who would take care of all of our equipment, they would have more privileges because they were administrators. Now that concludes my PowerPoint presentation with those top 20 terms. I have 3 references here, and these are the only ones that I use when I conducted the research for all of those definitions. But with that being said, I hope you have a great rest of your day, your night, whatever. I'm out.